Hello guys, welcome to our very first episode of TTT Talks. In this episode, I will be talking about determination of effective length factors. These factors are used when checking our Gusset compression buckling. Let's proceed. So first, we need to identify different gusset configurations. There are three main types of gusset configurations. So first are corner gussets, second single brace, third chevron braces. Under corner gussets, there are also three subtypes. First are compact corners, second are non-compact corners, and third are extended corners. Before we proceed, I need to show this table first. This table, you can see this table on Design Guide 29. You can get more info about this table here. But for now, as you can see, here these here are the different gusset configurations, the K factors or the effective length factors, and the different buckling length. I will discuss this further on the coming slides for each different types. So first are compact corners. Here's an image of a compact corner gusset. So compact corner gussets must have two edges of the plate that are connected to the supporting members. So in this example here, here's the first edge and this is the second edge, which is welded to the support. So both edges are connected to the support. It's either welded or bolted. Second, a line through the innermost bolts. So this line here, which is perpendicular to the brace line of action. So here's the brace line of action, and this line is the perpendicular, intersects one or both of the connected gusset boundaries. So this example here shows at least one of the of this line that intersects the connected gusset boundary. So this classifies as a compact corner gusset. Next, the brace member is pulled in close to the other framing members. So this criteria is met when the thickness of the gusset is greater than or equal to this equation. So where Fy is the yield strength of the plate, L1 and C are distances shown at the right. So here, L1, we usually have this dimension in our details, the unbraced length, and then this new dimension C, which we don't usually indicate in our details. And E is the modulus of elasticity of steel, which is 29,000 KSI. So here's this table again for compact corners. There's no value for K and buckling length because per note D, yielding is the applicable limit state for compact corner gusset plates. Therefore, the effective length factor and the buckling length are not applicable. So when we design compact corners, we don't need to check compression buckling. We only need to check the gusset for tension yielding. Okay? Next, non-compact corner. So here's an image of a non-compact corner gusset. First, two edges of the plate are connected to the supporting members. So similar to compact corner, two edges of the plate connected to the supporting members. So first edge, second edge. The brace member is not pulled in close to the other framing members. In other words, does not meet the compact corner criteria per equation shown. So this is the difference between compact and non-compact. So this is the compact corner criteria. If it will not meet this criteria, then it will be classified as a non-compact corner. So here in this table again, as you can see, for non-compact corner, the K factor is 1.0, but the buckling length will be L average. So in this equation here, L average or the average of the unbraced lengths where L1 is from the center, L2 and L3 are the outer buckling lengths. So as you may have guessed, this presentation may cause complication on our details. So since we need to show these different buckling lengths and the detailers might not interpret it correctly, or just simply because it will cause a lot of complication on our details. Because of that, we don't recommend using non-compact corner when designing our gussets. We only recommend this one when we are investigating existing connections. But when we design from scratch, we don't recommend using non-compact corner just because of this different many variables included with this approach. Next one are extended corners. So here's an image of an extended corner. First, two edges of the plate are connected to the supporting members. So still the same as the other two corner gusset. So here's the first edge and the second edge. Align through the innermost bolts perpendicular to the brace line of action. This line similar to the compact gusset, but now intersects both of the gusset free edges. So unlike the compact corner, this line must intersect to make it a compact gusset. This line should at least intersect to one of the connected gusset boundaries. But in this example, both are intersecting the gusset free edges. So this is now classified as an extended corner. So extended corner usually occurs on seismic connections. It's because there's a certain distance that the gusset needs to be pulled from the connected edge. It's a criteria in the seismic specification. So here in this table again, for extended corner, K factor is 0.6 and then buckling length is L1, or the center buckling length, as we are used to tabulating or showing this dimension on our details, on our current details. So design recommendation for all corner gusset. So here's our design recommendation when we are designing from scratch. So as I mentioned before, when we are investigating, we can use all the different connection corner gusset configurations. But when we are designing from scratch, we are recommending this approach now. So it is preferred that all corner gusset connections be designed as compact gussets. So we need to make sure our design falls into the compact gusset configuration. So this can be accomplished by meeting the following criteria. So first, the gusset thickness meets or exceeds the thickness calculated in the formula. So this formula, as discussed before. So the distance C is added to the detail as a maximum dimension. So here now, as I mentioned, this dimension, we don't usually show this in our details, in our current details, but in this new approach, we need to show this as a maximum dimension. Third, a note is added to the detail as shown. So to make sure our gusset corner configuration falls under the compact gusset, we need to make sure that this perpendicular line to the brace line of action must intersect to one or both of the gusset connected boundary. So we need to show, or we need to add a note on our detail similar to what's shown here. A line drawn across the end of the brace connection to the gusset should cross at least one welded edge. Increase gusset width or height as needed to meet this requirement. Okay. Next, the next main gusset configuration are single braces. So here's an image of a single brace. So only one edge of the plate is connected to the supporting member. So here, there's only one edge that is connected. Second, only a single brace connected to the gusset. So there's only one brace connected to the gusset. This single brace are also called sometimes as a knee brace or kicker brace. So here, this table again for single braces, K factor is 0.7 and then buckling length L1, which is from the center of the bolts, center of the innermost bolt to the connected edge. So the last gusset configuration are chevron braces. So here's an image. I think you are very familiar with this, as it's usually there's usually a lot of these types in our existing projects. So first, only one edge of the plate is connected to the supporting member. So it's similar to the single brace, only one edge. This one here, in this example, only one welded edge. So this can be bolted or welded, but for this example, it's welded. So two or more braces connected to the gusset. So unlike the single brace, there are now two or more braces that are connected to this single gusset. So here again, this table for chevron braces, K factor is 0.65 and with the L1 buckling length, which is from the center of the innermost bolt to the connected edge. Okay, that ends this presentation. If you have any questions about this presentation, don't hesitate to ask your mentors. Mentors, make sure to ask your mentees about what they learn about this presentation. Make sure that they really understood this presentation, because we need everyone to be on the same page when designing gussets now with regards to compression buckling. As you know, as you may have observed already, our gusset compression buckling approach, there are different key factors that are used in different projects. So this presentation is actually made because of that. Just so we are consistent all throughout different projects and our QC person are not confused as to which factors need to be used. So moving forward, we need to use this approach on our but if you are currently working on an existing project and if you're already using your own the previous approach, then don't bother changing it for now. We suggest using this new approach on a fresh new project or an existing project but haven't started designing gusset connection yet, horizontal brace or vertical braces. Okay, that's it, guys. Thank you for listening. I hope you learned from this presentation. If you have suggestions on our next topic, don't leave a comment. Don't forget to leave a comment, guys. Thank you again. Thank you for listening. Goodbye.